Hi class. Today we're going to review transformations of functions, and hopefully if you've seen this before, it might just jog your memory and get you back on track. If this is your first time seeing this, I'm going to try my best to explain what's going on so that you can also pick up some good notes for yourself. So, we have a function that we're calling the original function f of x. And we have a which is greater than 0 and c which is greater than 0. Okay. So if we look at the very first one, it says f of x plus c. So if you think about f of x in terms of what it means, it represents the y, all right, the y value of things. So this is saying y plus c. So that means I'm adding to the y value. So when you add to the y value increases. In terms of a function, what's happening is that you've just shifted the function upwards by c unit. So similarly, when you see f of x minus c, what it's saying is that take that function's y values and shift it down by c unit. So the graph shifts down c unit. And then if you have 3 says f of x plus c. So in this case, I'm adding a plus c to the input x. So that means I'm effecting a change on the x. So when you have x plus c, you are horizontally shifting the graph to the left by c unit. And then if you look at 4, it's a minus c to the x, which is the input. So again, you're effecting a change on the horizontal, meaning that you are shifting the function to the right by c unit. In 5, what you're trying to do is you have the negative multiplying the function. All it tells us is that you're reflecting about the x-axis. So all the y values switch. So you reflect about the x-axis. All right. And then if x is inside the function, the negative is inside the input x, what it tells us that the function is reflecting about the y-axis. Okay. So that's what's going on. Okay, with 6. And then 7, if you have a, which is the coefficient multiplying the function, if a is greater than 0, what really happens is that you are saying multiply the y value by a. You're literally stretching the function vertically by that factor a. And if a for 8, if a is between 0 and 1, then when you multiply anything between 0 and 1, it doesn't get bigger, it gets smaller. So you are shrinking vertically by that factor a. Now, 9 and 10, a little bit iffy. The understanding comes from a counterintuitive way. So a multiplying the input x, if a is greater than 0, you would think on a normal level that, oh, a is going to make this function stretch. But rather, what it does is that if a is greater than 1, it shrinks horizontally by a factor of 1 over a. And then likewise, if you have f of ax and the a is between 0 and 1, you would think that, oh, since it's a decimal, it's supposed to shrink, but rather it's a counterintuitive understanding. It stretches horizontally by a factor of 1 over a. All right, so we have all these rules that kind of guide us when we're trying to move point on a graph around. All right, so the best way to do this is to use an example. Okay, so I have this graph here that I want to try and move it from f of x to f negative 1 minus 1. So the first step is to recognize what is f of negative x. So f of negative x, if you go back to the table, is number 6. It says reflect. So 1 says reflect about the y. axis. So this is the y-axis. I'm going to reflect about it. So I'm going to go left and right. And then step 2, if you look at it as just the function minus 1, that's looking like step number 2. So I have to shift it down. So shift down by 1 unit. So I'm going to take these two information, I'm going to take each of the point and kind of do these two-step process. So if I look at the first one, the point I have is 3 and negative 1. So this is my y-axis, this is my x-axis. So if I reflect about the y-axis, so that is the y. If I reflect, what happens? It's the x that changes, but the y stays the same. All right, so I end up getting negative 3 comma negative 1. And then I'm going to move it down 1 unit, so I end up with negative 3, negative 2. And then I'm going to pick I'm going to pick 1 and 0. If I reflect about the y-axis, I end up getting negative 1 comma 0. Shifted, I end up getting shifted down by 1, so I end up getting negative 1 comma negative 1. If I go to the next point, which is 0 comma negative 1, when I reflect about the y-axis, I still get 0, negative 1. And then I'm supposed to shift it down by 1 unit, so I get 0, negative 2. And then if I go to the next point, it's negative 1 comma 0. So when I reflect about the y-axis, I end up getting 1 comma 0. And then if I shift it down by 1, I get 1 comma negative 1. And then I have the next point, which is negative 2, 3. And if I reflect about the y-axis, I end up getting 2, 3, and then I'm going to move it down by 1, so I get 2, comma 2. Then the last point is negative 4, comma 1. If I reflect about the y-axis, I get 4, comma 1. And then move it down by 1, so I get 4, comma 1, 4, comma 0. So let's kind of go through each of the points, the new points for where the new graph is supposed to be, and start sketching it. So I end up with negative 3 and 2, negative 1 and 1, got 0 or negative 2, 1 and negative 1, 2 and 2, and 4 and 0. So it looks like it went this way. That way. And that way. Okay. Alrighty, so that's how you want to do it. So here I just literally used the information from what the function was, got it in words, and then took each of the points and went through the 1-2 step for each of the points to get to the new point. So you have that graphical approach. Another approach is you will be given a function and be given a sequence of transformation for you to kind of figure out what the new function looks like. All right, so let's look at the first example that I have. So the first example says that I have f of x. My original function is f of x is equal to root x. So I'm going to shift it up 5 units. So what it says is I'm doing f of x plus 5, meaning that I'm just doing square root of x plus 5. And then 8 units to the right, meaning that I'm doing f of x minus 8 plus 5. So my final answer is x minus 8 plus 5, which is going to be equal to g of x. All right. Now let's look at the next example. The next example says that you have f of x equal to x squared. So my original function is x squared, and I'm stretching it vertically by 4, meaning that I need to multiply the function by 4. So 4f of x is equal to 4x squared. And then I want to reflect across the x-axis. So that means that I want to make a negative 4 f of x. That would give me negative 4x squared. And then shift 10 units to the right, meaning that I'm doing negative 4 f of x minus 10 will mean that I have negative 4. And then what happens over here is that the input was x, but now the input has changed. The input is x minus 10. So I take away the x away from the original function, and then I replace it with what? X minus 10 squared. So that becomes what g of x is supposed to look like. Now let's look at the third one. So the third one, I have my original function, which is f of x is equal to x cubed. And when I reflect about the x-axis, what it's saying is that I want to multiply the function by x. So here I'm multiplying negative x cubed. And then I'm shifting down by 5, means that I'm going to take negative f of x. And then I'm going to go minus 5, which means I'm doing negative x squared minus 5, which now becomes what g of x is supposed to be. And then I have the function again, f of x is equal to x cubed. And if I shift down by 5, this is saying do f of x minus 5. I end up getting x cubed minus 5. And then it says reflect about the x-axis. That means that I need to multiply the function by a negative. Well, that means I have negative x cubed minus 5, which is negative x cubed plus 5, which is what the new graph should look like, g of x. All right, so this is just following through each of the steps. And the big thing that can happen is not recognizing when you have an input x minus c or x plus c. What you're literally doing is that you are removing every x that you have in that function, and you're replacing it with the x plus c. Okay, so that becomes a big thing because it can get confusing. Am I adding a c to the x already there? No, it's you literally taking away that x and replacing it with a new input, which is x plus c or x minus c. Alrighty, I do have one last one to do. I thought I was done, but I have this one here which says reflect about the y-axis. So I'm going to do f of negative x, which becomes 1 over negative x. And then I'm going to shift 80 units to the right. So that means that I have f of negative, and in place of writing x, I'm going to replace it with what? X minus 8. All right, so that's what I was talking about. You literally take that x away and you replace it with whatever shift that you're doing, if it's x plus c or x minus c. Okay, and so the next move, this becomes 1 over negative. And so wherever I see an x, I'm going to replace it with x minus 8, which becomes negative x plus a. Okay. All right. So in the next example, what we're trying to do is I'm giving you the original function and I'm also giving you the transform function. And I want you to tell me the sequence of transformation needed on the original function to arrive at the new function. All right, so let's look at the first one. So the first one is square root of x. All right, well, my original function, it looks like I have an x plus 6 and then a plus 8. So I can see that I need to do x plus 6, which will make the function x plus 6. So what I did was I did a shift to the left by 6 units. Then I need to add a plus 8. So this is what I'm saying. I'm saying x plus 6 plus 8 gives me x plus 6 plus 8, meaning my next move after the first one was I had to shift upwards by 8 units. Okay. Now let's look at the next example. The next example says I have x squared and I want to arrive at negative 2x squared plus 6. So I see the x squared over there. That means that it got multiplied by 2. There's a negative saying that there was a reflection. And then after that, I added what? I added 6. So if I look at it from the function point of view, I have 2 times f of x, which is 2x squared. It's not cube. And then I need to multiply through with negative. So I get negative 2 f of x. So I multiply through with a negative, I get negative 2x squared. And then to get to the 6, I need to add to the function. So I'm getting negative 2 f of x plus 6 gives me negative 2x squared plus 6. So let's write out what we had. So we stretched vertically by a factor of 2. That was my step 1. Step 2 was reflect about the x-axis. And then my third step was to shift upward by 6 units. Okay, let's look at the last example. And so I have x plus 2 all squared plus 12 is the original, and I want to arrive at x minus 4 squared minus 2. So it changed from x plus 2 to x minus 4. There was a certain horizontal shift. So if you look at it from here, what do I need to make the input so that it will land me at x minus 4? I had to do an input, take away the x, and replace it with what? X minus 6. Because when I plug in x minus 6 for input, so wherever I see an x, I'm going to get x minus 6 plus 2 squared plus 12. That gives me x minus 4 squared plus 12. So here what I did was I shifted shifted horizontally by 6 units to the right. All right. And then that's my step 1. And then my next move is I need to change the 12 to a negative 2. So I'm going to do f of x minus 6 minus 14. All right. So if I do minus 40, if I add minus 14 to what I already have, then that becomes x minus 4 squared minus 2. So here, shift downwards by 14 units. So the examples that I've given so far, I hope that it kind of makes sense as to how we are moving things around. If you're given a graph, how do you do it? If you're given a function and you're supposed to transform it, how do you do it? And then if I've given you the function and it's already transformed, can you tell me the sequence of transformation that was performed to arrive at what we have? Okay. Hopefully this is helpful and we'll meet in class to talk about these.